So here move to this 3D case. For 3D case, there is 14 types of Bravais lattices found. We found, and here crystal system is 7 types of crystal system. So you may find little confusing, like 14 types and 7 types. Why this happen? Because Bravais lattice, look at here, simple, body center and face center. This type of cubic it's found in cubic crystal system, all this thing. So this formation of these 3 Bravais lattice is completely different process. Their orientation of this atomic structure is completely different, because in simple case they are at one above one, all these atoms, this type of orientation is there. For body center, the upper layer atom is just above the one point, at one point, and for face center case also this structure will be different, but both is under the cubic crystal system, because from outside point of view we see only the cube they form a cube. If we go to the if we define only the unit cell, then we found a cubic for this 3 cases. So as these 3 different Bravais lattice is here, but we found only we define in a group of cubic crystal system. And similar case here also. For tetragonal, there is 2 type of Bravais lattice. For orthorhombic, 1, 2, 3, 4 type of Bravais lattice is there. This type of thing you have to know. For rhombohedral, trigonal, and this is the condition here. Here this is the condition, and here this is the condition. This is the condition. So for this, you may find from there, you may understand this will be definitely a cube. All length are equal, and the angle between them also 90 degree. So this will definitely a cube. This is very easy to understand actually, and you have to visualize this also. And our next class will be regarding this also, because after that you may find atomic packing fraction, all this type of thing. So I will give some example of this. Then tetragonal, this is the condition will be there. This also there is 2 types of Bravais lattice is there for tetragonal, and this type of thing. Total 14 here. Total this will be 14, and this will be 7. So for interview purpose or for just 1 mark question, this type of thing will be asked just as to check your basic knowledge. So how many? Sorry, it's not this 14. How many Bravais lattice is there? Total 14, and crystal system is 7 crystal system is there. So in the previous class I told you that there is infinite number of unit cell may present, but only 14 is we discussed about only 14, because this happens because of the symmetry operation. So only this 14 exists we see in our nature, and we find in any material, this 14th Bravais lattice. This happens because of this symmetry operation. So I hope you understand this. Now I am going to move to line indices. Line indices. So what is actually line indices, and what is its important? So first we have to know what is actually line indices. Is just the equation of line between 2 points in a unit cell. So what is this important? Why we need this line indices in our study? So I will discuss about this. So first I will tell you what is line indices actually. Let's draw a unit cell. And for understanding, we define this dimension is unit dimension. For understanding, I draw this. So let's draw a unit cell. This is cubic. This is cubic. And let's suppose this is the origin 0 0 0. And if we draw any line from, let's suppose we connect these 2 points, this is the origin point 0 0 0, and we have to define axis also. This is x axis, let's suppose this is y axis, this is z axis. So what is the equation of this point? What is its coordinate? This point will be, this will be an unit dimension, so 1 0 0. So these 2 points you consider, and line indices. Line indices is our topic. Let's forget about this now. So what is this equation of this line? So you already understand, you already learned, I think. This equation will be we have to subtract from this point to this point, and this will be the equation. And if the equation, if the coordinate of any, I will tell you, I will give you with an example later. This what I am going to now wish to tell you. So first you have to subtract from this point to this point. So what will be your initial point? Let's subtract x1. This is the x2, y2, z2, and this will be x1, y1, z1. So these 2 points. So subtract x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. This will be the actual equation of line indices. So what will be in this case? 1 minus 0, 1 I cap, and all other term will be 0. So this will be the line indices for this case. This is the equation of line, and what will be the line indices? Plus 0 j cap plus 0 k cap. So what will be the line indices? Line indices is 1 0 0. This will be the line indices in this case. So we define line indices in this way. I hope you already came to know about this, like this bracket, and in some other case we have to define this type of bracket also. In some case we have defined this type of bracket, and in some case we have defined some other types of bracket, this type of bracket. So this all you have to know in which case this bracket is important, in which case this curly bracket is important, in which case this angle bracket will be important. So this is this is also important to know for line indices case. For if we want to define a line in unit cell cases, so we have defined this type of bracket here, and if we have to define a family of line, then this type of bracket will be useful, this type of, and these two will define for Miller indices, these two. So I will teach this after not today's class, after some 2-3 class later I will go to this Miller indices case. So this will be like in this case for this line, this will be the line indices for this case. So I hope you understand how you have to define line indices, and how you have to find out the line indices of a line. So similar case, if we draw this line, what will be the line indices? If we connect this line, these 2 points, so what will be the line indices? Let's suppose this at the corner from this. What will be the line indices in this case? So what is the position of this point? In the x-axis 1, in the z-axis 0, in the y-axis 1. So this will be x-axis 1, y-axis 1. In the z-axis this will be 0. So what will be the line indices between it at this line, and direction is important here. And look here, in this case the direction is like this. Direction is important. In this case, now I am going to calculate line indices from this point to this point, and this is the direction. So same formula, apply the same formula, this formula. So in this case, 1 I cap plus 1 j cap plus 0 k cap. So line indices will be 110 in this case. And remember, this is for this direction. And what happen if you define this direction? In this case, if you define opposite direction, then this will be 1 will be -1. And in case of line indices, we define minus like we use bar to define the minus case. This for opposite direction. So this is different. And here also this if the direction is different, then we use this as what 1 for opposite direction. So I hope you understand this line indices part. And now I am going to teach you why line indices is important in our study. Now I'm going to teach you why line indices is important. I hope you already know about this, like magnetization topic. You know about hysteresis loop and all this time magnetization, this graph of I will tell you like this. I hope you already know this about this hysteresis loop, like this type of structure you already know, I think. Here is magnetization graph. This is at different types of H for if you let's suppose if we put a magnetic material near a magnet, then this type of magnetization will happen in this case. So at this magnetization at this point of magnet, this magnetization will be saturate. Like if we increase this H value also, this M will be saturate for this case. This is the hysteresis loop. So I hope you already know about this one thing. So this phenomenon, this saturate magnetization, this H is saturate magnetic field. This saturate magnetic field will be different for different direction. Like if we apply this for this case, let's apply magnetic field in this direction for this material. What happens if the magnetic field apply in this direction, in diagonal direction, in some other direction? Then this M value will be different. This H value will be different to get saturate M value. H value will be different. So sorry, H value will be different to get saturate M value. So this type of graph, I hope you already know about this. Let's suppose this. So here at this point, this is the saturation point. There is HM graph. Here is the saturation point. There, this is the saturation point, and there, this is the saturation point. So what is what is the meaning of this different saturation point, different H value for same type of material? So this only happens because when we apply magnetic field in this direction, let's suppose in X direction, then this type of at this point this saturation will happen. So this graph is for this direction 0 1, this 1 0 0 plane, and this graph is for, let's suppose we next apply this at this direction. Let's suppose this plane. We apply magnetic field at this direction along this plane. I hope you already know this type of plane we consider. So in this plane, along this plane, in this, if we apply this magnetic field in this along this plane, then this is the saturation magnetic field H2. For this case, this will be for along this plane. We have to calculate the direction, like at this point. So let's suppose any 1 0 0, let's 1 1 0, let's suppose 1 1 0. I have to calculate actually what will be this line indices for this point. So it takes time to do some calculation. So let's suppose 110 at this direction, and for this case, let's if we apply this line magnetic field in diagonal direction, like suppose from this point to this point, from this point to this point, this type of point, one point is there, one point is there, diagonal, this point to this point, from inside point to outside point, corner. So then this type of magnetic field is important to get saturation magnetic field. So for this case, let's suppose 111. So these three direction define different types of magnetic field to magnetize this system, to reach the saturation magnetic field for this system. So what is the conclusion of this study? So from this study we defined as, it's important to understand this line indices, because for different lines there is different types of magnetic field we require to get this saturation point. So that's why line indices is important in solid state physics. So now I'm going to tell you what is the meaning of this bracket. So now I'm going to tell you about this. So this is nothing but a family of this what's called lines, family of these lines. There is an equation, this like L square plus K square I square equal to H square H square. So this is the equation, is very important. This is the equation to define the family of lines. For this, let's suppose 100, these lines. So all the line indices, all the properties same for all these lines which satisfy this equation. Let's suppose for 100, then what will be this equation? H square plus L square plus K square will be, for this case, this will be 1. For 0, 1, 0, then this value, apply this value. This also will be 1, because H will be 0, K will be 1 in this case, and L will be 0. So 1, K square equal to 1. For this case also will be 1, as in negative direction, but square will be 1. So for this case, then will be also 1. So for all these lines, this line are different, like this lines is this lines will be like this line will be like this, and minus bar will be like opposite direction. So from upper point of view, from outside, a person will say that this line are different, but their properties, all these properties of these lines are same. Let's suppose here also, for this case, all these lines, magnetization in all this line will be same value. H1 value will be same for all these lines. So that's why it's important to define a family of lines to study these properties. So that's why it's important to what's called this a family of lines. So that's very important. For now, I'm going to tell you the different type of family of these lines. So I have to erase this. So for this family, what will be the line? Let's suppose in this family, what will be the line present here? Here present this line 100 is present here, right? Then 010 will be also present. Then 001 also will be present here. Then what about the others? Others will be 1 bar will be also there. Then 1 bar 0 will be there. Then 1 bar 0 will be also there. Then 1 bar also will be there. I hope only this 1 2 3 4 5 6 will be there in this family. So this family have 6 members. You have to know this type of question may be asked in interview. So what is the case? 1 1 0. In this case, what will be the member? So in this case, let's calculate. 1 1 0 will be 1. Next will be 0 1 1 will be also 1. Then 1 0 1 will be 1. Then what will be this others? And bar will be there. 1 bar 0 will be there. 1 bar 1 will be there. then 1 0 1 bar will be there, and next 1 bar 1 0 will be there, 0 1 1 bar will be there, 1 bar 0 1 will be there. How many? 1 2 3 4 5 6 7 8 9. Then what will be left? Yeah, 1 1 double bar, 1 bar 1 bar 0 will be there, 0 1 bar 1 bar will be there, and 1 bar 0 1 bar will be there. I think this is the only, this is 1 2 3 4 5. This 12 will be total member, and for this case 1 1 1 also you have to calculate this. Yeah, I think there in this case total 8 will be there. It's 1 1 1 will be there, then 1 bar 1 will be there, then 1 bar 1 will be there, then 1 bar will be there, then 1 bar 1 will be there, then 1 bar 1 bar will be there, then 1 bar 1 bar will be there, then 1 bar 1 bar will be there, total 8, this 8. So in this case total 8 members of this family. So I hope you understand this line indices part. So in the next class I will teach you about Miller indices for this case, for solid state unit cell. It's Miller indices actually defines a plane. For further study like reciprocal lattice, all this thing, this plane is important to know. So in this case I hope you understand for today's all these things.